In this video, we are going to discuss queues and their implementation. As before, I've developed an interface for a queue using an abstract class, and the methods we're going to implement are add to back, which adds an item to the end of the queue, remove from front, which removes the front item, peek at front, which peeks the front item, get size, clear. Now, there is already a built-in queue type in STL, but we're showing how to implement it under the covers. So let's start with the most basic implementation using an array. So we declare a pointer to the first element in our array. When we call the constructor, we have a default capacity, create a queue of that size. When we're done, we're good citizens, we clean up our queue. Then, when we get add to back, what we're going to do is check the size, and if we've exceeded our capacity, we're going to increase the size of our array, copy the old array over, and delete it, just like we did in the queue example. Then we're going to add it to the back of the array plus one mod capacity. So basically, it will loop back around. We won't overload our the mod capacity is most likely unnecessary, but it will allow us if we put something in the end item. Remove from front will chop off the first item in the range. Notice that it throws an exception if we're out of bounds. Similarly with peek at front, this time just returns the front item. Whoa, I'm sorry, I missed something here. When you remove it, we move across the, we just move the front pointer over by one, or the front index over by one, and based on the capacity, that front index will grab. Sorry about that. And so that's the implementation using an array. Using a linked list we wrote before, it's pretty straightforward as well. We have our linked list data structure that we're going to implement as a queue. And this is pretty simple because we've already done a lot of the work here. We have inserted back for add. From remove from front, we get the head and then remove it from the front. Similarly with peek, we just check to see if the queue is empty and get the head, and so forth and so on. And finally, we've got a vector queue, which is another implementation using, this time instead of a queue, a vector, or an array. The reason I wanted to do the vector queue is just to show you, because the underlying structure has a lot of the things built in, this becomes a very simple implementation. One thing that is common is implementing certain data structures using other data structures. So this is a good example of that. And then finally, I just built a little run routine, which runs through, adds a bunch of items to the data, and removes it. Again, it uses polymorphism, so I can pass it in any type of queue. So now, if I run this, here you go. So there you go. That's your quick overview or introduction to how to build a queue.